This is just a short video to reiterate how to find the equation of a tangent line to a curve, and also to talk about normal lines and how we go about finding those as well. It's pretty straightforward. The concept's fairly easy to grasp. We've already looked at it previously with some of our examples for differentiation, so I'll just do one example of each, and hopefully that should see you through. So just going back to tangents to start with. So tangent to a curve has the same gradient as the curve at that point. So at this point A, this red tangent line has the same gradient as the curve. Okay, clearly as we move around, then the gradient will get steeper here and less steep over here. But that's what we're finding. So if we find the gradient of this line, then we also find the gradient of the curve. Now sometimes it's actually useful to find the equation of that red line itself. The steps to do this are pretty straightforward. Firstly, you need to differentiate the function. That will give you a gradient. So that gives gradient, or it gives you your gradient function rather. Then you find the value of the gradient at the given point. So there has to be a point specified. You have to have an x value. So you need an x value, and you substitute that in, and that will give you the gradient at that point. Then you just use the gradient and the coordinates of that point to determine the equation of the tangent line. Okay, so if that's not all that clear, hopefully it will become more clear when we do an example. But basically you need an x, y, and a y value, so a coordinate, a point, the coordinates of a point on the function. So on the original function that you're interested in. Okay, and then you can check it with your class pad, and I'll show you a couple of ways of doing that. One's graphical and one's sort of more algebraic. You can do it just in the main window, and I'll show you both of those. So let's get straight into it. So we're going to find the equation of the tangent to this curve at the point where x equals 1. Now, straight away we know that we need to find out what is the y value, because we'll need that when we want to find out the constant of our tangent line. Okay, so if we say y, when x is 1, it's going to be 1 cubed plus a half times 1 squared, which is just 1.5. Okay, so we'll come back to that later. So first thing is differentiate, dy dx. Okay, bring the power down, reduce the power by 1, plus bring the power down, reduce the power by 1, that's still over 2, those cancel. Okay, now when x equals 1, that means we'll have 3 times 1 squared plus 1, okay, which just gives you your gradient equals 4. So now, now we have the gradient. So going back over to our tangent line, we know the gradient is 4. So m equals 4, that's the gradient. Goes through the point 1, 1.5, which is what we found up here. Okay, because it goes through that point on the curve. Therefore, we say y equals mx plus c, which is 4x plus c. Okay, and then if we substitute these values in, we get 1.5 equals 4 times 1 plus c, so c must be minus 2.5. Therefore, the equation of the tangent is 4x minus 2.5. So this is equation of tangent. So I've stepped this out fairly systematically and thoroughly, going through and showing you every little bit of work here. You don't need to be quite this thorough, providing you understand what you're doing. So equation of tangent line. Okay, now if you want to check this, always good to do it by hand and then check it with your class pad. So let's pull up the class pad here. Okay, oops, we're a little bit out of frame there. Okay, so move it over to this side. Alright, so we're going to check what our value is. Now the first one, I'll show you how to do it using just through the calculation menu. Okay, so we just need x cubed plus half x squared. Don't put y in front of this, don't put y equals, because it doesn't like that. So just put it in as the right hand side of the equation. Interactive calculation, come down to line, tan line. Okay, I showed you this before. Put in the point 1, okay, and it tells you the tangent line straight away. So 4x take 2.5, that's what we got. Good stuff, got it right. Okay, the other way of doing it is to actually go y equals and graph it. We can do it with a with an image, and I like this because it really shows you what's going on. Alright, so if you bring this down, so you've got your cubic, and if you go up to analysis and you go sketch and tangent, okay, so it shows you a tangent and it usually defaults to the origin or some point on there. If you want to find the point that you're looking for, so when x equals 1, just tap execute. Nope, sorry, tap 1 and it'll come up, bring 1, okay, and that will show you this line. So that's the tangent at that point, and then if you tap execute, now it will give you down here the equation of that line. Okay, so 4x minus 2.5. So I might just clear that and do that again because that was a little bit murky. So clear. Right, so bring the function down. Analysis, sketch, tangent. Okay, it'll bring up this green line. Tap the number that you want for the x value, so we want 1. Brings up this enter value, x value equals 1. Hit OK. That gives you a tangent, but it hasn't told us the equation of the line. To get the equation of the line, hit execute and it'll appear in here. So if you watch in here, there you go, 4x minus 2.5. Okay, so I like this way because it really gives you that visual representation of what's going on, which I find is always helpful, especially when you're learning something for the first time, and it can be a little bit confusing about what you're doing with your differentiation and how you're finding the tangent lines. So get used to using this and it'll just make your life a bit easier as well. Okay, so moving on to normals. So a normal is similar, except that it's perpendicular, so at right angles to the tangent. Alright, so if you've got a curve here, this is your curve in blue, and the red line is your tangent, okay, and it goes through this point, make this black, goes through this point here, whatever that point is, call it P, okay. So you've got a tangent that goes through there, then the normal is at right angles to the tangent, and therefore to the gradient at that point, but it still goes through that point there. So we can find the normal in exactly the same fashion as we find the tangent equation. It's just one more step. So find the equation, that should say normal, tangent. Find the equation of the normal line. Okay, differentiate the function, find the gradient at the given point, then you need to find the perpendicular gradient, so that's the extra step. Okay, find the perpendicular gradient, remembering that gradient 1, when you've got two lines, the gradient of the first times the gradient of the second must equal -1 if they're perpendicular. So use that. Then use the perpendicular gradient and the coordinates of the point to determine the equation of, sorry, this should say normal again, of the normal line. And then you can check with your class pad in exactly the same way. So we'll do another example, and I'll show you how to do it by hand and then how to check it. Okay, so first thing to note is they've given us the x and y coordinates, which is good, so we don't need to work out the y coordinate in this case. So just jump straight into differentiating. Divide x, 3x squared, take 4x. Okay, at x equals 1, gradient equals 3 times 1 squared, take 4 times 1, or -1. Okay. And then we need to find the perpendicular gradient. So perpendicular gradient is just going to be -1 on this. So over -1, which gives you 1. Okay, so now the equation of the normal. We know it's in the form y equals mx plus c, so it's a straight line. Okay, we know the gradient is 1, so it's actually just x plus c. Y equals x plus c, m is 1. M equals 1. Okay, and then we can put this value in. So -1 equals 1 plus c. C must be -2. Therefore, y equals x minus 2. And now this time, we found the equation of the normal. Of the normal line. Okay, so again, you can do this on your class pad in exactly the same way, using the same two options. So if we clear all this again, and this one, Okay, so what we've got first is x cubed minus 2x squared. Okay, and we're going to go up to calculate line normal. The point we want is 1 again. Okay, x minus 2. Excellent. That's what we got. And then if we want to see what that actually looks like, do our y equals, bring that down, pop that in here. Okay, nice little function there. Analysis sketch. Now we're sketching the normal. Okay, and the same thing applies. So once you've got your line, tap the point that you want. So we wanted 1. Brings up x value equals 1. Yes, it does. Okay, and if you want to change it at that point, you could. And now you can see that it's drawing a line that is perpendicular to the curve at that point. Okay, and if you want to know the value, so the equation of that line, keep an eye out in here, hit execute. There you go, y equals x minus 2. Okay, and that again just gives you that nice graphical representation of what's going on, so you can see that it's actually at right angles. Just be mindful that if your scale's a bit squiffy on here, so here it's nice and even where the horizontal units are the same as the vertical units, but if for some reason you've been playing around with it and your horizontal units are stretched out, this won't look like it's perpendicular. So just be aware of that, and remember you can always go zoom default, do it that way, or the other way is zoom initialize, which will do the same thing. And that'll bring it back to this nice even grid that you've got there, so it actually does look like it's at right angles, which is always comforting. Okay, so that's all there is to it. So just remembering that the gradient of a curve at a specified point is given by the gradient of the tangent at that point. So to find the equation of the tangent, use the point gradient method. Okay, determine the gradient, run it through that point. Okay, the normal is perpendicular. So when we start talking about things being normal to each other, we mean perpendicular, right angles. Okay, this is some terminology that'll pop up sort of from now on. So it's normal to the tangent, and it goes through the same point, and then you just do exactly the same thing. So calculate the perpendicular gradient, so just that extra step, differentiate, find the gradient, calculate the perpendicular gradient, and then use the point gradient method as well. So pretty straightforward.